All right, so let's do this review on the electricity. Let's see, you start out, you observe a string of lights and notice that some are lit while others are burned out. Is this string of light a series circuit or a parallel circuit? Well, if it was a series circuit, they're either all on or all off. There's no halfway or no middle ground. So this has obviously got to be a parallel circuit. Parallel, they can, um, electricity goes around a burned out bulb because of the wiring. So that's a parallel circuit. Number two identical bulbs are placed in series in a circuit. So that's one after another. Later on, the circuit is rearranged. Using the same battery, but now the bulbs are placed in parallel. Okay. Compare the brightness of the bulbs when they're in series to when they're in parallel. Well, if we remember, when they're in series, when we add up the resistances go up and the current goes down. So if the current goes down, the lights are going to be dimmer. If we look at the resistance in parallel, resistance goes down when we put things in parallel, so the current goes up, and therefore those are brighter. So lights in series will be dimmer, lights in parallel will be brighter. A circuit runs on a 12-volt battery, so this is a car. If a physicist measures, or most likely a car, if a physicist measures the current to be 4.17 amps, what is the resistance of the circuit? So that's just going to be our basic Ohm's law, V equals IR. So 12.0 equals, our current is 4.17, and then R. So R is just, we're going to divide, we get 12.0 divided by 4.17. Do a quick little math, 3 significant digits, so we get 2.88 ohms. A motor draws 15 watts of power. If it runs on a 1.5 volt power source, so 1.5, that's a AA or AAA, so maybe we're talking about a remote or something very small like that, maybe a mouse or toy. What current does it draw? Well, we know our main equation for power would be P equals IV. That's the definition one. We have power, we're looking for current, and we have volts. So let's just plug in 15 equals, we're looking for I, and we have 1.5 for the volts. So again, quick little division. I equals 15 divided by 1.5, and that comes out to exactly 10 amps. Determine the effective resistance of two resistors in parallel. So parallel, that's the reciprocal one. So we're going to have 1 over the R equals 1 over 117 plus 1 over 291, which that comes out to be 0.0120. Remember that as 1 over R, so we got to do the reciprocals of those. So R equals 83.4. Now, you need to practice this. A lot of y'all are missing this on your quiz, so you need to make sure you practice that to make sure you can do that math. Use your calculator. Now we're going to do the same two resistors, but in series, and that's much easier. In series, we just add them together. So that comes out to be, let's see, 8, 0, carry the 1, so 408 ohms. All right, make sure you know the difference between parallel math and the series math. All right, determine the power drawn by the circuit powered by 12 volts and 3 resistors, 18, 21, and 22, in series and in parallel. Okay, well, let's get the effective resistance of both of those real quick in each case. So we just add the resistors for series. So that comes out to be 61 Parallel, it'd be 1 over each of those. Make sure we get the decimals in there. So with the reciprocals, use the calculator, we get 6.73 ohms. Now those are just the effective resistors. We wanted, the problem asks us to find the power. So P equals IV. So we're looking for the power. We have the volts, but this is resistance, not current. So we can use one of the other power formulas. So we'll look at our formula sheet, and we would have V squared over R as our alternate one. That's just using V equals IR to get the different forms. So power equals, voltage is 12. We're going to square that, divide by R, 61.0. So if they're in series, we draw 2.36 watts. If they are in parallel, 12.0 squared over 6.73, we have 21.4 watts. So we can see things in parallel are going to draw a lot more power. We're going to use a lot more energy. All right. If an electrician has 1, 3, 6, or 10 amp fuses, what should be used to protect the circuit? Because remember, that's what a fuse does, is it protects the circuit from high current so they don't melt. Powered by 12 volts, so we were both in cars again in this case. Using 3 resistors, 43, 54, and 63. So again, let's go ahead and figure out the effective resistance for both cases. In series, again, that's the easy one. We just add those together. We get 160 ohms. For parallel, it's the 1 over. So it's 1 over 43, 1 over 54, plus 1 over 63. Do our math. Again, make sure you practice this, that you're coming up with the same numbers I am. I got 17.3 on that one. So, to figure out which fuse we need to figure out the current that's being drawn. So here we need I. We have the voltage from the battery, and we've got the resistance. So that's just V equals IR. We're going to solve for the current, so we're going to divide voltage by the resistance. The voltage for the top one is 12 divided by 160, which gives us 0.075. So that's way low, so that's going to be 1 amp fuse. It's kind of a weird problem because I'm trying to do series and parallel examples on the same thing, so I'm getting little slightly weird numbers, but that's okay. But definitely not going to use like a 10 amp fuse for this low of a, oops, this is amps, this low of a current. And then for this other one, we can use the same equation. I equals the voltage, which is 12 divided by 17.3, and we get a current of 0.694 amps, which is, again, this is a better example of a 1 amp fuse.